Hey, yeah, so we have a motherboard here. Time for another video. This board, I picked it up at the flea market the weekend, and first thing I noticed when I saw it basically is there was damaged pins in the socket in this area. Yeah, and it looked a bit bad, to be quite honest. But I could get the guy down to €10, and I thought, well, I can probably fix this, and it'll make a good video if I can't. So it's money invested in learning all this stuff. Yeah. So this is the board, and I thought possibly even some of these pins might be broken off. But if we zoom down in on it, let me just get the camera in focus lower down. Okay, I've got that zoomed down. Yeah, you can sort of see that there's like something metal in there, like not just a hole, but they look rather nasty. The other thing with this board is I don't know what the history of this is. I mean, this was at the flea market with some damaged pins in the socket, but the question remains: have those pins, been damaged while it was at the flea market or in somebody's car? Because obviously there's no cover on the CPU socket. Let's try to focus a little bit. Yeah, so I mean, has it been damaged at the market, or was that the original problem? Or was there something wrong with this, which is why it was there anyway, and that's how it got damaged, yeah? But before we can do anything with this, obviously, the first thing we need to do is have a look at these under a microscope and see if we can actually, straighten them. Are they missing? Are they bent? Are they broken? So let's go over to the microscope and let's have a look to see what we can actually see on this board. Yeah. Okay, I'll just go to the microscope camera. Okay, so the camera's working. Let's have a look to see what the problem is. So as often as not, these look worse than they are. So just looking at it, they look bad, and when you get into the microscope, you can see. So here, I think you can see there's one there which is sticking up in the air. Another one here. Another one here. That's 3. Another one there, 4. Another one here, 5. So there seems to be 5 pins here which are just sticking up in the air. Yeah. And then there seems to be something else damaged. Yeah, there's one over here which is just bent. Yeah. So I'll look down the microscope because it's much easier to do this. I can't do this just on the screen. I need stereo vision, which is why you shouldn't buy those USB microscopes. They're no good for this. They're great for seeing what the problem is, but you can't work with them to repair them, I tell you. Okay, I'll just try to get the focus. It's good on the microscope. Now I just try and adjust the focus on the camera as well. Yeah, I think that's pretty good. So these ones I'm hoping they just want pushing back down again. Let's try this one first. Push this one down as well. I'll come back to that one. Yeah, that one's going down quite nicely. I'm not opening the tweezers, I'm just literally using the ends of the tweezers to push it. Yeah. Another one here. That looks pretty good. Another one here. That's pretty good. A bit too low. What else was there? There's one here. Okay. The way to do this really is you can see that like the pins like running a horizontal line. If you look at the ends of them, the shiny bit, you want them to be like in lines, yeah, like a square grid, so the ends running down in straight lines and across in straight lines. I mean, that one's slightly out there, but it's so close it's not worth worrying about. Yeah. And that's how you want them to be. So we can just focus that again. There you go. So those ones straight away have gone down quite nicely. Let's Let's look at the other one. Now this one's bent a little bit to the side. These can be a little bit more fiddly actually, the ones that where they've gone to the side. But yeah, let me just see if I can get in and push it back. I've ordered some new tweezers, by the way. My tweezers are getting beat up now. Yeah, maybe just a little bit more than that. That one's still slightly bent, but they don't have to be exactly exact, if you know what I mean. Close enough is like good enough mostly with these things. Again, let's focus in on that. I'll just zoom back out of it. Yeah. Got the focus, okay. Yeah, so that was pretty good. I mean, looking at the socket now without the microscope, it actually looks good. Let's go back to the overhead camera. Okay, I think you can sort of see it just looks like a little darker just here where I've been straightening the pins, but we know they're not broken, we know they're not missing, and that was pretty good. Again, you can just about see the one here that was just slightly pushed to the side. Yeah, so that I think looks good enough now to just try. Let's get a processor in and have a look. So what does this board take? It's an LG A1155, it's saying. Yeah, 1155. Socket 1155. I'm not sure which. Is that 6th generation or something? Let's have a look. Let's have a look what it is. So what was the board? Yeah, GA-Z77X-D3H. Let's have a look to see what this takes. Okay, so it was a GA-77X. No, Z77X. D3H. 3H. CPU list. There'll be quite a few sites that should give us this information. I missed a dash out of here. Does that make any difference? Come on, come on. Give me a page. Is it just me who thinks like the internet's got slower since like you get all stupid advertising all the time, and it can't, like the advert doesn't load? Yeah. Okay, CPUupgrade.com. That's a good one. This will tell us what we want to know. Z77 Express. Let's see what it takes. I can see some Celerons. Oh no, it's actually an older than I thought it was. 2nd or 3rd generation. Yeah. 2500K. Yeah. 2nd generation. Okay, let me have a dig around in my little stash of parts. Yeah. Let's see what we've got that will actually fit in this. Okay, so if you're going to be doing this sort of repair work, you're going to have to build up a collection of stuff like this. This is where I keep the RAM and processors basically. As you can see, I've got, giving out this DD4 memory here, DDR3, DDR4, DDR2. So these are just like, you know, ones I've gathered together over the a year since I've been doing this. I think all these here DDR400. This will depend on what sort of work you want to do. As you can probably see, I do vintage stuff, bit of error correction memory, DDR2 for servers, a bit more DDR3, a couple of them, and some PC133. That's what I keep. Now, say this will depend on what you do. I'm doing a whole mixture of vintage stuff right through to modern stuff, so I have to keep all those sorts of memory in stock. Yeah. Processor wise, I've got a Pentium 2. This one's a Celeron. That's an old, like the Pentium 3 type. I think that is. And this is a Pentium 3. This might be the old Pentium actually, not the original one, but the Pentium one. There's another Celeron. So, you know, I'm keeping a mix of these. That's an AMD, that's a Ryzen no, it's not. It's an A6 processor. Works in some Ryzen motherboards. That's a Ryzen. It's a Ryzen 3. So with these, where I'm having to buy them, if I can't find any old second-hand ones, I'm still buying used ones, and I kind of like look at the motherboard specs of chipsets and find like the cheapest processors, which are usually the slowest ones, yeah, that'll work. So yeah, I mean, this lot here, this is mainly Pentium 4s, and sort of like socket 775, Pentium 4s again, dual cores. There's a whole range of those in there. What else do we have? Pentium 4s. That's an empty bag. They've got effectively like socket 775s there, dual core. This thing. What's this one? I think this is some sort of probably socket. What's it? It's a Xeon E5 2620 Xeon. Yeah. Just off topic 2011 socket 2011. And I have another one that works on like that. That's like a Mark II, and I have a Mark III. Then we get into like this stuff. So i5 530. That's like the original generation of Core i3 i5. Yeah. That one's another one, i5 650, so they'll be basically working like the original i3, i5, i7 boards. i3 6100, this will work I think in the 270 or 370, 390 chipset boards. No, I think that works in the 370. This one's Celeron G4900. That works in the 390. Motherboard Z390. Again, I'm buying a Celeron. Yeah, I'm not going out and buying like an i7 9000 or 10,000 because I don't want to spend the money. I want something to test it with. So buy Celerons. Yeah, as long as it's supported. And back to where we were. It looks like this one. This i3 2120. That's a second generation. That's a fourth generation. That's just an empty bag. G840. That's a 1155. Yeah, G840. So I'm guessing one of these two here will fit my board. So if you're doing motherboard repair, this is the sort of thing you need to be getting together. I didn't go out and buy all these all at once. Some of it came from second-hand boards I was getting from the flea market. Sometimes it's just when I could get a motherboard that I don't have a suitable processor, so I then go and buy the cheapest suitable processor I can find. Yeah, so that's my little stash of RAM and CPUs, and that's the sort of thing you should be looking over a period of time to put together. Again, this will depend on what you want to be doing. If you want to be fixing just very up-to-date stuff, you'll need just a few processors. Yeah. I do have, by the way, a few other AMD, AM2 Athlon processors and a couple of others. They're on motherboards. I'm looking behind me. They're on motherboards I've got there. I have a socket 478 board. So they're like a complete boards and processors for a few of the older type of ones. I had some 486, but I sold that one and a few others because it was worth so much money. I don't see many of the boards. Anyway, enough about that. So let's see, either i3 2120 or the G840. I think one of these will fit this board. Let's have a quick look and see what's what. So i3. These are all i5s. i5, have you got some i3s out? Here are i3s. So i3 2120 I have. That's i330s, maybe these don't fit these boards. Oh, i3 2120, yeah. So look, again, it's like one of the cheapest ones I could find, so effectively it's just slow. You know, it's just a dual core, it's not as valuable as some of the other ones. So that would fit it. And also the G840. No, that's for a different generation of board. Yeah, okay, so we have an i3 2120, so we've got a suitable CPU, so that's a good start. So yeah, let's put this in, and then I think we won't bother with RAM. Normally if I'm powering up a board I don't know, I don't bother with RAM. Let's have a quick look first to see if we have any short circuits. Yeah, it's probably easier to check for short circuits with the processor fitted, because if you've got a high side FET without the processor fitted, you may not see a short, yeah, from the 12 volts. If you put the processor in and you have a short on the high side FETs, you'll see the resistance of the CPU, which is a few ohms, yeah. So let's have a quick look to see if we have a short circuit on the high side. So one side of this connector will be 0 and one will be 12. So let's have a quick look. So yeah, these are ground. So it's the other side. Now, there's no short there. Got a little bleep. The capacitor charged. So high side's okay. Yeah, we'll see. Capacitor charged, yeah. Low side we can test, but I'm pretty sure that'll be good. Easiest way to check the low side is from the V coil under these coils, yeah. So any of these coils here. So we'll go from the coils and we'll go down to DVI connectors. It's a good place anyway to find the ground. Right, you're reading the low resistance of the CPU now, yeah. 18 ohms. So if I take the CPU out, you'll see you won't read that. I'll just take the CPU back out. So if we go back to the coil again, you won't. I think you shouldn't see such a low resistance. Yeah, it's high now, yeah. So if you had a short circuit on the high side MOSFETs, you would read from 12 volts to ground at 18 ohms, and that's the CPU. So you don't see a short, but you see the resistance of the CPU, and that's the easiest way. I mean, the other way is to check for short circuit from the 12 volts going in to the coil, yeah. That's the other way if you don't have a CPU. Okay. Okay, so that's good. Cmos battery. We need the Cmos battery. Let's just find the Cmos battery. Okay, so we've got some Cmos batteries. These should read about 3.1 volts, yeah. If they're good. 3.0. That might be a little bit drained. If they're less than 3, certainly. Yeah, see 2.92, that's not a particularly good one. Let's have a look at this one. That's no good at all. Bin. Let's look at this one. That's for the bin. Let me find some more, so find some good ones. One moment. If I can't find one this way, I've got a load of new ones, but let's just go through these. I've got a little tray of old ones here. Let's see what we got. Any that read less than 3, I don't like them. I think all these are no good actually. This little tray. Oh, that one's okay. 3.09. No one. What else we got? Yeah, that's probably all right. Looks like I just have a few good ones in here. Yeah, that's probably all right. And let's have a look at this last one. Yeah. So now we've sorted the men from the boys, yeah. They can all in the bin. One of these looks like it's okay. Stick that in there. Another good idea to check is what the current draw is off the Cmos battery. This is not something like it's going to go bang or anything, but it will give you a good idea of whether the real-time clock's running, yeah, because if the real-time clock ain't running, you're not going to get any anything happening. It's not going to start up, yeah. I use this because the microamps range on this is better than the one there, basically. It's more sensitive. So the way to measure this is set the meter to microamps, yeah. This is my little Aneng AN8008, nice little meter. positive to the Cmos battery, and then you put your negative to the clip, and you push the clip away from the battery, so the current is passing through your meter. I'm expecting this to read anywhere from 1 or 2 microamps up to 4 or 5. Certainly less than 10. If it's in the milliamps range, there's a problem. 1.88 microamps, yeah. 1.8. That's fine. That's good. So I'm fairly confident the real-time clock's running. CPU. So we need a fan. Let's get a fan. There we go. Little bit of a heatsink compound. Will do. Got the fan. These won't touch the board. If you watch the videos, you've seen this before. So it's just a fan I can actually rest onto the CPU. Connect the fan, because quite often boards won't power up without it, or they'll power up and power back down again. Yeah, that's that. What else do we need? We need a power supply. Huh? Our known good power supply. And I think we'll just zoom this out a little bit as well. Yeah, okay, so we've got a known good power supply. Just checking the desk, make sure there's nothing, stray bits of metal or anything on here. We don't want them in the way. Does this thing have onboard video? Yeah, it's got a DVI, so we don't need a graphics card, so that can sit there. It's got a PCI, so let's stick the analyzer card in as well. Let's have the post analyzer. Where's that? Where's that? It's here, post analyzer here. So let's put that in the PCI slot. Power. Let's have a 8-way, yeah. 8-way for the 12 volts. It's in there. Yeah, just the on-off switch now with the speaker. Obviously, I'm expecting this to be making bleeping noises because there's no RAM at the moment. It's DDR3, not DDR4 as well, so we'll need some DDR3. I was getting ahead of myself and I thought it was DDR4 power switch. Okay, let's grab a power lid and then let's just see what happens. Okay, so we got power. So it's switched off at the moment. What's the isolation switch? So we have power on. I think that's everything. I think all we can really do now is just switch this on and let's see if it bleeps. Yeah, see if it switches on and see if it bleeps. Yep, we're ready to go. So power's on, power supply is on. Let's see what it does. Fan's running. It's bleeping. It's making a fast, continuous beep, 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 beep. Was that just saying there's no RAM in here? Oh, I've grabbed a bit of DDR3, so see what we got. There's a couple of Samsungs here, 1 gig strips. Yeah. Again, you know, just keep the minimum you need. Like you're saying, DDR3 1, 3, 2, 4. So I think we can, without reading the manual, assume one of them goes in 1 and one of them goes in 2. Yeah. It seems reasonable. It seems reasonable. 1 and 2, yeah. What else can we do? Focus it up a little. Yeah, that's everything. So it doesn't now. Shall we switch the power back on? And it's still making this continuous beep, 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 beep. So there's something wrong with this. Oh. making a rapid, continuous beep, 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 beep noise. Does that mean one of the voltage rails isn't running? Like, is VCore not running? I'm thinking I've heard somewhere they make that continuous bleeping if there's no VCore, yeah? So in other words, it's saying like there's no CPU. I wonder if that's what's going on with it. Oh, a good way to tell, first off, is there's a processor getting warm, yeah? Just wipe this bit of stuff. Wipe a bit of pigeon shit off here, yeah? Always used to call this stuff pigeon shit in like the 70s and 80s. This heat sink compound. Pigeon shit. That feels completely cold to me. I'm going to fire it up just with my finger on here and just see if it actually warms at all. No, it doesn't. There's no warmth and it's beep, 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 beep. Right. Does that have a problem with VCore? Easiest way to do that is just measure it, yeah? Where's the easiest place to measure VCore on this? Underneath it. Yeah, underneath it. On the coils. The fact it is making a bleeping noise tells me something's active, if you know what I mean. There's some circuitry obviously active enough to get it to make this sound. I might be able to measure it. There's some capacitors down here by the coils, yeah. I'm focusing on you. Yeah, there's some like little capacitors down here by the coils, and I'm wondering if they're actually on VCore. So the test meter, let's have a look. If I can measure it from this side, it's just easier, that's all. If they're on VCore, I should see the resistance of the processor to ground, which was 18 ohms, yeah, off one end of the capacitor. Another end will probably be ground. That's probably ground. 70. No, they're not on VCore. They're not on VCore. There's some more over here. 17 ohms. Yeah, that one. So that I'm pretty sure will be VCore, because 17 ohms is the resistance to the processor. If I release the processor, yeah, it's gone. Like, put the processor in, and we know that the VCore had 17 ohms from the other side, so that's VCore. So that's a good point to measure this, yeah. So we just pop the black meter lead in there, we'll just stick him in there, yeah. 17 ohms. Okay, let's put that to volts. Let's get on there. Let's put the power on first. Let's see if we got any VCore. Okay. Yeah, we have 1 volt. That's about right. We got VCore. Okay. So continuous beep 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 beep, regardless of whether the RAM's in or not. Let's go and Google it. Yeah, let's just go Google that. So we'll put the model number in on the internet, and let's have a look to see what. So it's the GA-Z77X UD3, I think. D3H, yeah. Continuous bleeps. See what that means. Continuous beeping noise. Solid bleeping tone says that the fan has failed. PCI graphics card not being seated. Well, we're on onboard graphics, but I don't have a monitor attached. I hear the fan spinning. Yeah, this is what I thought can be 12 volt E80X power connector being loose or incorrectly fitted, but we know we've got VCore, so that isn't the case. In other words, basically, somebody's taken the effort here to write to tell the person who asked the question that I don't know the answer, and that's the best solution. Yeah, right, okay. Memory not located, continuous short beep. Okay, guys, that didn't tell us a lot, did it? So I think the next thing on this is going to be, let's look for some obvious stuff like by checking all the main voltages are there. Yeah, do we actually have all the voltages we expect? So we got V-core. We know we got V-core. We should have VRAM, which I'm guessing is going to be, well, down here somewhere. Some more coils here, some more FETs here. Sorry, you can't see them. Okay, so we have at least 1, 2, 3 more power supply rails here. I wouldn't be surprised if these two are going to the RAM, and this one might be VREF or something, which is half of VRAM, I think, but I don't know this chipset particularly. Let's have a look. So if we go on to the around these MOSFETs, we should either find on them either 12 volts, or whatever voltage coming in for 3.35, whatever voltage they're generating in ground. Let's have a look, see what we've got down here, just off interest. See if we've got any voltages. I'll put the fan back on, sorry, the cooler back on, because obviously we do have V-core. Yeah. And let's have a look down here and see what we can find. Okay, I've just managed to prop that into the ground. Yeah, I've got a connection to ground, so that's okay. These look like input capacitors. I'm going to go to the outputs of these FETs, yeah, and have a look. Let's have a look, see what we can find some voltage down here. I'm expecting VRAM about 1.5, and if it's VREF about 0.75 or something. .5, yeah, that's what I was expecting. So that appears we've got VRAM. Oh, and it stops bleeping after a while. Oh, and it reboots. Bleeping again. That could be ground. That's probably 5 volts coming in. If that's 5 volts coming in, you'd expect to be some voltage here. Yeah, that one doesn't seem to be doing anything. Needs to be investigated a bit further. Oh no, 5 volts. 5 volts. That's got 5 volts both sides of it. That's seems a bit wrong. These are 1.5. This must. I'm guessing this is VRAM. We know we've got V-core. I've got a FET down here with a coil bite with 5 volts on both sides of it, and that's got to be ready to investigate. Okay, let's before we have a poke around there, let's see if we can find, if we're lucky, a schematic for this one. Yeah, let's have a look. So it's a Z77X. Let's see if we've got any schematics available for this. Yeah, let's have a look. Gigabyte, you can quite often find schematics. So it's the GA-Z77X D3H schematic we're looking for. Got to spell it right, Richard, and then you'll probably find it. Schematic, yeah. User mail drawings. Well, it looks like there are schematics for this. Oh, well, yeah, VineFix. This is a pay site, and I have actually in the past subscribed for a month when I wanted some schematics. Well, but I'm not a member at the moment at VineFix. I am, but I'm not like a VIP member, so I can't actually download anything at the moment from here. But these obviously have them. Let's have a look on bad caps for them, because this is where you'll probably find them for free. There's a couple of places we can look. We'll look on bad caps, yeah. And we can just go into search, forum search, okay. We can go and search for, is it Z77X? I keep forgetting the last bit, D3H. 3H. Just have a quick look, see if there's I can see a schematic thread. There's lots of threads on this board. I'll put the search a little bit narrower and put schematic. Nothing came up in the schematics page, it would have said. So let's have a look on schematic X. That's another place. See what these have got. Schematic X. So Gigabyte. Z77M. That's close. It's not the same. Let's have a Z77X. Ah, there we go. Got it, guys. That's the schematic. Yeah. So this will be rather helpful when we're trying to fix this. Come on, give me the link. Give me the link. I mean, sometimes you do have to go to pay sites, so there's no doubt about that. Oh, come on. You threatened to give it to us, yeah? Revision 103. Wonder what my board is. Can't see particularly. Well, I've got the link anyway, yeah? So that's the PDF. So we'll download that. So let's have that, yeah. Okay. Well, let's have a quick look at it and see what we actually have. Downloads. Okay, Gigabyte. Let's do it the other way. I'll move it to a sensible folder later. Right click. Extract to. Okay, so what have we got? Yeah, here we go. Nice block diagram, and we have the schematics. Okay, guys, so this is going to be useful. We can now use this to figure out when we find the voltages. Let's see what voltage we have. Yeah, let's see what voltage rails we should have first. That's probably the very good place to start with this one. I'll have a browse through. It's a big page, and when I come to the I'll have a quick look if I see it now. If I can't see it now, I'll go through, then I'll show you the sum here, 3 joule, 5 joule, VCC3, but I'm sure one of these pages actually will be, that's the PCH, one page will be the power somewhere, yeah, PCI Express, PCIe, BIOS, audio. This looks like a power supply. No, this is the inputs, audio inputs. These look powers. These are power supplies. V-core phases. Yeah. So we can have a look around here and make a note. Yeah, more CPU, VTT power. This is what we need, guys. So I'll have a look around here and figure out what voltage rails we should have. I'll look at the that FET I was trying to find, Q41, that has 5 volts on both sides of it, that I wasn't too happy about, or seemed a bit strange. Oh, in fact, it's there, Q41 FET. Funny enough, there you go, it looks like it does have 5 volts on both sides of it. Okay, but with this we can definitely start to work out if we have all our power rails, or our power rails. So guys, it's tomorrow. I was a bit tired that first half of the video was the last night, so I left it at that. Anyway, yeah, so we know we can get schematics for this, so that's good. We know briefly that I was just measuring down here. We've got VRAM, we've got V-core. I did a bit of a Google as well, just to see, you know, if this is something other people have had, so I thought it must be. So I put the model number and the motherboard and like continuous beeps, yeah, and I found it's yeah, other people have reported this, and there seems to be like a bit of a mixed opinion. Like, some suggestions, and people are saying that it's when you don't have the PCIe 12 volts. Sorry, not PCIe, where the ATX 12 volts EATX here. Yeah, but I've got V-Core, so I can be confident I have got that. Otherwise, you couldn't have V-Core without that, and it's plugged in. There are other voltages we could check, but the main, or at least for the RAM and the processor, the main supplies are there at least. So the other suggestion was this can be like faulty RAM or incompatible RAM, and some people saying that like if they put RAM in one channel it works and not the other, like they've got some sort of problem like dirt in the sockets or bent pins in the CPU sockets, dirt in the RAM slots, that sort of thing. Anyway, so let's just pursue that method first, and let's see whether we can determine if it's just down to RAM. So let's power it up. So as it powers on, I've got, it's not bleeping today. It switched itself off, the fan's gone off. And on the post analyzer, there's a light lit up, a red one. Oh, it's gone off now. CPU light was on. Switched itself back on again. CPU light's on. Oh, CPU light's gone off now. Oh, it's booting a bit further. Oh, what's happening here? It's booted. It's booted. Yeah, I've got a picture on the screen. Aye. I could only suggest the problem with this was like dirt in the RAM. So it's gone off again. It's rebooting, it's restarting. Let's see what happens this time. Now it's gone back to the PC. Let me show you. This is the post analyzer. Yeah, let me show you what it's doing. It's booted once, so we know it can boot. That's a very good sign. I wonder if the problem with this is like CMOS settings or something stupid. Yeah, let's have a look. You can see it's booting up. Yeah, it goes on to 1.5. Mostly it was just stuck on 32 here. But that one time it did, it actually booted. No bleeps anymore though, that's interesting. So, I'll put this there, you can see that. Okay. Well, that's interesting because it's booted once and then this RAM. Right, okay. This DIMM isn't in. I've only got the one, so I've got one DIMM in slot 1, DDR3 1 is the slot number. And the other one was actually just sitting there, it wasn't actually plugged in yet. Okay, let's just try it with the one RAM. That's what we get. The fan's gone off. Even though this is still on, the fan stopped spinning. Fan's spinning again. It's reset on its own, or switched off on its own. No, yeah, it's restarted on its own. Ah, see 4F. Here we go. Ah, then it powered off. Well, the last time this went to 4F and whatever, I actually got a picture. 4F 72. Here we go. Bleep. Gigabyte UFE BIOS. And then it switches off. It's still trying to boot up. I think I'll try and clear the CMOS. I can see that this has two BIOSes here. There's two chips, M BIOS and B BIOS. So you must be able to somehow switch between the main and the backup BIOS. I need to get the instruction manual and see if that's something we can do by changing a jumper on the board, because we can assume that that's meant if it doesn't want to boot up. So we'll look at that next. Okay, I'll go and have a look to see if we can switch between the two BIOSes. Otherwise, I'm tempted to blow as much dust out of these as I can, reseat the CPU again, check again for any bent pins, and if possible, it wouldn't be a problem, I can actually remove one of the BIOS chips and just actually, like, you know, make sure it's programmed with the latest BIOS that supports this CPU. Okay, first let me go and have a look to see if I can actually see any way to switch between the BIOSes with a jumper. Okay, yeah, I had a look. It seems that the BIOS, the dual BIOS, it mentions this is the motherboard user manual saying it supports dual BIOS, and it basically says it automatically selects, so if the main BIOS is corrupted or damaged, the backup BIOS will take over on the next system boot, yeah, so it just switches automatically, yeah, and then it effectively copies the backup to the main on its own. For the sake of system safety, users cannot update the backup BIOS manually. Can they not? They haven't met Richard, have they? But yeah, okay, so we could quite easily reprogram the BIOS with an EEPROM program, either the main or the backup. But let's just pursue a little bit further then. I checked the RAM configuration. It was, you know, as I guessed, it was like 1 as a single DIMM or 1 and 3 as dual. You can use 3 as a single DIMM. And it seems to me there might be just a problem with these slots, so I'm going to repeatedly insert the RAM a few times, yeah, and see if that helps. So we're still on the single channel. The camera fell over, so that's the post analyzer if you want to see that. Let's switch the power on. Yeah, we're on. Let's try that, see if that boots. No, it's stuck on the 32. Notice it stopped that horrible bleeping noise though. The speaker's attached, the speaker's there, the wires haven't fell off or something stupid. Okay, it's restarted. I wonder if this is where it's kind of switching between the main BIOS and the backup BIOS, possibly. Oh, you see. Yeah, I wonder if the main BIOS is corrupted. Then it reset again. I think this is a candidate for reprogramming the BIOS, you know. To be quite honest. Now it's booted. And we've got a picture. Do we keep a picture on the screen? No, then it goes off. And now it restarts again. And sticks on 32. I'm going to, I mean obviously I'm not waggling anything around, so that's not making any difference. Let's try clearing the Cmos, see if that helps us. If this doesn't help, I'll try another memory to make sure it's just not some compatibility issue. At the moment we're on single channel, but if we get to work on single channel, then we can look at dual channel afterwards, yeah? Let's see if we can get this to actually boot up reliably. If the other memory doesn't work, I'm going to desolder the main BIOS. I'm going to go and find the latest BIOS update for this and program it myself, and then fit it back on again, and then we can take it from there. Only thing with that, of course, if it doesn't boot, it's then going to overwrite what I've written with the backup BIOS. Maybe maybe I should program both of them, you know. I can always, obviously, I can read the contents and save that as an original, so I can always put it back again. It's not a problem. Okay, so let's try clearing the Cmos, switch it back on. So what she does now? Stuck on that 32 again. I'll just try reseating the CPU as well. Nothing lost there, is there? Nothing looks bent in the socket now. The CPU's clean. I mean, I can check the pins. There's one down here that still looks a little bit bent actually, so maybe we just need to check that one. Yeah, let's just check that one, because one does look like it's bent. Let's just see if I get the microscope into position. Oh. There we go. There we go. Okay, let's move the power supply as well. Move everything this way. Yeah. Knock all the cameras over while I'm at it, why not? Yeah. Let's have a look at this socket once again. Plug in the microscope camera for you. Okay, let's see if we got a microscope cam. No, we haven't. Give me a second. Okay, got a microscope camera. I can see one pin somewhere in this area. That one. Can you see it? I'm sure you can see it because the light's catching on it differently from the other ones. But that isn't bent. Well, if you look at the little gold pin on the end of it, and you have to try and like, sometimes you have to squint a little bit, so like all the pins effectively run in like vertical lines. Yeah, that one doesn't look bent enough. There's one above it looks slightly, but I don't think these are causing a problem, to be honest. This one is slightly out of line. This was the one that's just kind of like shiny. Just move it upwards a little bit. Okay. That looks in line now. You can see on the screen, can't you? Like it's reflecting the same as all the other ones were. Okay, let's give that a go. See what that does. One of the dims have gone under the board. We don't want that, do we? We don't want anything under the board. Okay. Let's have the camera on the post analyzer. There you go. Power on. Boot. So that's me. Oh. Still stuck at 32. Is it going to restart and then? Oops. One moment. I need to put the ow fingers. I need to put the heatsink back on the CPU. One moment. Sorry, CPU. Yeah. So we go. Going any further than that? See if it just give it a few seconds. See if it restarts. There we go. See, then it goes past it. I'm suspecting BIOS on this, guys. I will just try with my other memory, just to be sure it's shut down again that time. Yeah, goes past it again. Yeah, that's booted. You hear the bleep. I've got a picture on the screen. It's trying to load into the BIOS, but then it shuts off. Yeah, so it's like when it tries to load the BIOS, it shuts down. Switched it off. Let's have a look. This is a bit of course there. I've got a couple of sticks of this. 1333. It's quite reasonably good RAM, this, I think. Let's other way around. There we go. See what that does. The same. That's what that does. We'll just try both channels of RAM again. Let's see if this restarts after it's done this little bit thinking about it. There it goes. Should come back on again. There we go. Now it boots. Goes off. And I think sometimes it's the third time it comes on, it actually then goes and gives me a picture on the screen which just says Gigabyte BIOS, and then it goes off. There we go. It's quite predictable, isn't it, actually, what this is doing now. We can see Gigabyte UEFI dual BIOS, and then it just goes blank. I wonder if this point it's trying to write, you know, the backup BIOS back to the first one and fails, as it mentioned in the manual. Okay, let's just give it a quick go with the other RAM. Okay, dual channel. Let's see what this does. Oh, 32. Yeah, this is the same, isn't it? It's 32. At least it stopped all that horrible bleeping. I have to put that down to dust in the sockets, I think, because I can't think of anything else that changed. So the processor fan's off now, even though this is effectively still stuck at that. Yeah. Then the processor fan spins once, then it should come back. Yeah, there we go. And this is gonna, I assume, boot and then reset. Yeah, and then the next time should boot give me a picture saying dual BIOS and then reset. Here we go. Here we go. Well, we can reproduce this exactly. We know exactly how it's going to behave. Yeah, Gigabyte UEFI dual BIOS is on the screen. Give it a few seconds. Screen goes blank and it resets. Okay, guys. Yeah, I think the next step with this is going to be to download a bin file for the BIOS, the latest one, and reprogram both of these. No point reprogramming just the first one. Or is there? Yeah. I'll reprogram both of them. Let's just get it done with it. Okay, let's get out the EEPROM program and the hot air, and let's do that. See you soon, guys. Hi guys, so I've desoldered the EEPROMs from the Z77X motherboard. There's two, there's a main and a backup, which are both the same. And basically to read them, this is my programmer. It's a Mini Pro TL866A, yeah, that's my programmer, TL866A. And to read them, basically, I have to solder the BIOS chip onto you know, an adapter depending on the type of chip. So this is one of the BIOS chips. Yeah, it's SOP18, SOP6, and that's the type of chip. Yeah. So what we'll just do is now have a quick look under the microscope, see what type of chip it is, and just make sure it's soldered properly. Yeah. So I'll just get the microscope one moment. Okay, so this is the chip. You can see I've used this adapter many times. I suspect sooner or later I'm going to have to buy another one of these because this is a very common size for EEPROM. Although I suspect I could probably just make something, but I bet I can get one of these for like €1 or something. So yeah, there's the chip. It's I think you can see the part number. It's 25L6406E. 25, yeah, 25L6406E, yeah. So we need to make a little note of that. I'll find a bit of paper to do that on. Okay, so 25L 6406E. 6406E. So that's the chip. Okay, so I'll just check what I have it under the microscope just to make sure it's soldered properly. It looks okay, but usually the torch is the best way. Just have a quick look. Yeah, they look like they're soldered down okay. And let's have a look on the other side. Looks even better. Okay, so I think that's soldered in place. We'll soon find out anyway if the programmer recognised it. Okay, so what we need to do with this, we need to program it. So this is the programming. Yeah, it's quite a simple thing. This you just put the chip in. It's marked here with a 1, yeah, and there's a marked 1 here. There's a dot on the chip. This chip is, I made a little scratch mark just there. You may just see it. This is the backup. Yeah, I've actually already done the main one. Save you watching this twice. So this is backup. Okay, so that's in the programmer. Actually, I'll set it to the right chip first. So we'll just take that out of the programmer and connect to the USB. Yeah, and let's go to the desktop and let's do this. desktop cameras. Oh, there we go. I'm there. Okay, so the programmer that I use is this one. They're about 30 or 40 euros, I think it is. We can look it up a bit later to see how much this actually was. Yeah, so we have to select the IC first and put in the part number. So 25L 6406, and here we have 6406E, and SOP8, SOP8. That was the package. That's what it said on the adapter. So we can select that. Yeah. I'll now put the chip on the EEPROM programmer. I won't bother change cameras. I'm just going to drop that in into the. In fact, no. Let me show you how these go. Let's do everything. Yeah. Let's do everything. So, yeah, the adapter basically pin 1 has to go into the pin 1 on here, and it's a bit awkward to get this in. It doesn't quite fit. You have to just drop the lever slightly, then you can get it into position. Yeah, that's now in the programmer, so that's ready to read. Okay. So basically we've selected the type, and all we need to do now is just to read it. So R to read. It's recognised it. You see there's an ident there. That's some data in the chips. That tells us it's the right chip basically. So obviously it was soldered right. So yeah, let's just let us program. Then what we'll do is I've already programmed the other chip, the main one. Yeah. Sorry, I've already read the main one. Yeah. So we're going to read this one. We can go and check just to see if they are actually both the same, because according to the motherboard manual it's supposed to copy the backup into the main, yeah, as a backup. Oh, so if it's been doing that, they should be the same. Regardless of that, we'll then download the latest BIOS we can find for this board, and we will actually write that. In fact, while we're waiting for this to just program, let's go get a BIOS. Okay, so we want GA-Z77X-D3H BIOS. That'll do. This is Gigabyte's website, so that's a good place. Now our board, I believe, is a revision 1.1. I'll just check that, but I'm pretty sure ours is a 1.1. Let me see. It says in some corner or other on the thing. Revision 1.1. Okay, so we want a 1.1 BIOS, I suppose, for this. So let's go to Gigabyte website. But it didn't follow. Let's just put Rev 1.1 in as well. Oh, it did do it. Okay, this is the one. That's a 1.0. Let me see if I can find a page for Rev 1.1. I mean, obviously it's important we put the right revision BIOS in. Yeah, Rev 1.1. There we go. Quite simple, I would think. Support. Downloads, BIOS, and there we have, there's the most recent one, yeah, download. Okay, no, that's the folder. This is what I actually downloaded the other day just to try it. That's why it says it's already there. I'm not sure if I got the right revision yesterday though. That's finished reading our chip, by the way. It's saying it's successful. So we'll save that. I've already saved main. I told you I'd already done this once, so if you're watching this twice. This is the backup, yeah. Back. Save that. Okay. Let's go to the folder where we now downloaded the BIOS file. Easiest probably way, just go to here, folder here. Right, this is the folder. I'll delete this. This is the one I downloaded the other day. I'm not sure if it was the right one or not. So this is the download, this file, yeah? and quite little. We need to extract this, so just extract it. There it is. And here, this is like an easy flash utility, but we can't use this because we can't boot the board. But this here, although it says it's a 1BI file, 1BI, no, 18i, it's an 8 megabyte file, and that I think is the bin file. It's the right size, yeah, that's 8 megabyte. If we go and find the other files, in a different folder. Okay, let's find the file. GA. I should have put them both in the right place now. There we are. These are the two files that we saved, yeah. So that's an 8 meg file. So yeah, it appears that the file that we have is a bin, yeah. I may have to change its name to bin actually to get the programmer to read it, but we can have a go. Okay, so that's an 8 meg file. This is the one we downloaded, so let's have that as well. Copy that one. Right, there's a new one, and I'll just rename this to bin. So the programmer should open that. Okay, right. Okay, so we have 3 files now. The first thing I'm interested to know is if these two are actually the same, and maybe if they're the same as that one as well, yeah? So, I have a program called examdiff, which is free, basically. We'll have a look at this one. No, I don't want a new version, this is fine. So we're going to compare, yeah? So we're going to be looking for, find the folder, GA, this one. This is the backup from the board, yeah? That's strange it doesn't remember the folder. Okay. This is the main from the board. Okay. And I'm interested to know if these two are actually the same. Oh, it's suggesting there's a problem with the file in backup bin. No new one. Yeah, like there's some difference already between the two, yeah? That's going to take a while. So, in fact, no, we know they're not the same. We could say in here straight away there's a difference between these two files, yeah? It's not happy with that. Okay, let's not bother with the comparison now. Let's just write this one to the chips and then put them back on the board. Okay, so Mini Pro, open, and we want, this is the one we downloaded, open, binary format, just accept that, yeah. It's normal to find big areas of FFF in the BIOS like this, there's nothing unusual about that. And anyway, this is the downloaded file. Let's write this to the EPROMs. So, the EPROM's still on the programmer. We've still selected the right type. So we're now going to program. Program. Just going through, obviously it's saying erasing now. It's just going to go through a couple of cycles of this. If it starts to take a long time, I'll pause the video. There we go. Okay, I was going to pause the video while this actually writes. Okay, it's just about done now. Actually, I think that exam diff was just saying something about the format of the file, rather than maybe there was something wrong with it. But it was obviously going to take a long time to do that. So we'll program this one. No, it's still going to take a bit longer. Okay, one more pause. Okay, it was actually verifying this time. It's almost finished the verification, so it's just checking that it's written correctly. Here we go. Yeah, programming successful, so that's programmed. So what I'll do now is I'll program the other one. and then we'll put them both back on the motherboard and let's see if it now boots. Okay, so I've soldered the two BIOS chips here. Just give it a little bit of a clean. It was looking nice. I didn't dislodge any components. There's a couple of capacitors down here. Those were spare anyways. There's a few more here, little components. Looks like a resistor and a couple of capacitors. Do them in the right way round. The dot is by pin 1, and that was good to go. So I will now basically connect all this back up and let's see if it boots. Let's see if we've actually got the thing into the BIOS now. Okay, so we're all set, ready to go. I mean, we don't know that the BIOS was corrupt. It's one of these things, you know, we have a board that's kind of cycling on boot. Try different RAM. Well, we tried different RAM in different slots. Is the processor compatible with the board? Well, we know this one is because we looked it up before we set up. We actually looked to find out what processor we can use with it. After that, really, BIOS, you know, so it's one of these things. There's no direct way, really, I think you can actually prove it's a corrupted BIOS. It's more one of these things that it's like a process. So when you get to a certain point in the fault finding, which we did, then we go for the BIOS. Okay, so just connect a speaker in case you get any beeps out of it, and we'll just connect the power switch. We'll power it on. You can see the little post analyzer here. And if you remember last time, we went through 3 different boots effectively. On the third one, it gave a screen which just said BIOS, and then it crashed again or went off. Yeah. So power's on. Everything's connected. No, power isn't on. Power's on now. Everything's connected. Start. Oh, well, something's different. It doesn't like that, does it? I'm sure that's the right BIOS for this board. I'll just check the soldering around the BIOS chips, make sure they're properly soldered. We know they're in the right way round. So we'll give that a check and see if there's a problem there now. Well, they looked okay, but I have just resoldered them again. It might be one pin wasn't connecting. It was a bit hard to tell, to be quite honest. So I've resoldered them, but I'm just going to check now, make sure there's no shorts or anything here. But it's just shutting down like this. So let's just go. Yeah, that's fine. I've got the power supply plugged in now. There's no shorts there. This was V-core down here, which would need 17 ohms with the CPU. Close enough. There's no shorts there. No short on 3.3. 12's okay, 5's okay, standby's okay. Yeah, I mean they're all okay. No shorts there. So I've taken the RAM back out. So I've just got the processor and the motherboard again now. Let's get the. Let's just see what happens. I'll get the post analyzer. Okay, so power's on. Right, it stayed on this time. And it's bleeping to say there's no RAM. Oh, that's interesting. I wonder if it appears I hadn't got one of those EEPROMs soldered properly. I mean, that was the last thing I was doing, so that's obviously the first place to look, yeah. I mean, I'm 99.9% sure we have the correct file. Yeah. Analyzer card, RAM's back in, power's back on. Set the monitor. Let's see what it does. Now it's 15. Is it gonna? Oh. Okay, fan stopped. Oh, hold on. Put the fan on the CPU. I'm looking at the fan and thinking, hang on a sec, that belongs somewhere else. No, this can't possibly short to anything. The legs on it are too short to do it. Won't reach. I think she's behaving differently. Yeah, it's booted on the first attempt now. And, aha, okay, there we go. BIOS is being reset, yeah. We fixed it, guys. It looks like we fixed it. Okay, so I'll have to get a keyboard and just go in. But before, all I could see was this bit at the top here. Yeah, I could just see that, and then it crashed. Now I've actually got something on the screen. Okay, guys, so what I'll do with this one then is I will now set the BIOS, attach a hard drive with a known good Windows 10 on, and see if it'll actually load up. If not, I'll install a Windows 10 and see what that does. Okay, but I think we've got a fix here. Okay, guys, so there we are. I've installed Windows 10. Well, actually, I haven't installed Windows 10. I've used the hard drive off Test Rig, which already had Windows 10 on it anyway. And I just installed the various drivers. But yeah, it's running. It's stayed stable during all that time while I was installing drivers. This is Specky. You can just see here the processor. It's just got 2 gig of RAM on at the moment, which are those sticks I used. The Z77H-D3H, sorry, Z77X-D3H, and this is giving us, you know, lots of information. This is Specky, this program, just telling us a bit about the motherboard, and everything looks to be good. Everything seems to be working fine, so I think we'll have to declare this one a successful repair. So as you can see, there were a few interesting things to learn from that video. The most interesting to me was the fact that I hadn't soldered the BIOS chip correctly. There was at least one pin that wasn't connecting, and in doing so, the board was power straight on and straight back off again, almost like you have a short somewhere, which is why I was checking to see something, you know, like there hadn't been something underneath the board that was shorting or something like that. Obviously there wasn't. So that was very interesting. So yeah, if you get motherboards that are like it's stuck in a loop, you know, like a boot loop, and sometimes, as we saw, that won't even start at all, they turn on and straight back off again, and there's no shorts, then clearly the BIOS is one of the next things to be looking at. This motherboard, I'm guessing somebody effectively did a BIOS update, you know, using when it was working, using the update utility, and probably put the BIOS on for the wrong revision board, and that was enough to stop it from working. Yeah, I'm quite pleased with the results of that. Hope you enjoyed this video, and I'll be seeing you all very soon on another one. Cheers now.